Okay, let's have a look at what's called the quotient rule. So the quotient rule is very like the product rule, except it's used when we're differentiating quotient. So a quotient looks something like this. It's when you've got something divided by something else. So the quotient rule goes, if y is equal to u over v, so if you remember when we did the product rule, we had if y is equal to u times v, but this time we've got something over something, the u part over the v part. Then it says that dy over dx is equal to, and this looks complicated, but it's actually quite simple. It's the v part times du over dx, and remember du over dx is just the u part differentiated, minus u times dv over dx, all divided by v squared. So we'll do an example using that now in a second. If you prefer the function notation, here it is here, the quotient rule says that if f of x is equal to u of x over v of x, so a function divided by a function, then f dash x is equal to v of x times u dash x minus u of x times v dash x all over v of x squared. So these two things are exactly the same. It's just a different way to write. So let's have a look at an example of differentiating something using the quotient rule. So say we have this, and we'll do it both ways. So we want to differentiate we want to differentiate 2x minus 3 all over x squared minus 4. So it's a quotient. It's something divided by something. So we'll start off over here. We'll use dy over dx. So we're going to start off by writing y is equal to this. So 2x minus 3 all divided by x squared minus 4. So u is the top part. So u is equal to 2x minus 3. And v is the bottom part. So v is equal to x squared minus 4. And now, because I've got a u and an x, I can find du over dx. I can just differentiate. So du over dx would be, we'll differentiate 2x, we just get 2. And differentiate minus 3, we get 0, because it's a constant. Here we can find dv over dx. And we get differentiate x squared, we get 2x, and differentiate minus 4, we get 0. So then by the quotient rule, if you look here, I'll write it down again, sure. We have, by the quotient rule, we have dy over dx, which is what we're looking for, is v times du over dx minus u times dv over dx all over v squared. Okay, so that's the quotient rule. Now I just need to put these things into it. So dy over dx, what we're looking for. So dy over dx is equal to v, so x squared minus 4, times du over dx. Du over dx just means u differentiated. So du over dx is 2. So times 2 minus u. So u is 2x minus 3 times dv over dx, so times 2x. All divided by, and it's all divided by v squared. So v squared is x squared minus 4 all to v squared. So all divided by x squared minus 4 all to b squared. And now it's just a matter, we can simplify that, we can multiply out the top line. So we've got, that's the same as, okay, we've got x squared by 2, so we're left with 2x squared. Minus 4 by 2 is minus 8. Just be careful of this sign here. We're multiplying this bracket by this bracket, but it's minus 2x by 2x. So that's going to give me minus 4x squared. And be careful here now, it's minus 3. So that's going to be plus 3 by 2x, which is plus 6x all over. Don't worry about squaring out the bottom, just leave it as x squared minus 4 squared. So that's just x squared minus 4 all to be squared. You can add up like terms, so we've got 2x squared minus 4x squared. I'm just going to squeeze it in here. So the answer, dy over dx, is equal to 2x squared minus 4x squared is minus 2x squared. And we've got, is there anything else we can add up? Well, we've got minus 8 plus 6x, so just leave minus 8. So 6x all over the v part squared. So x squared minus 4 squared. And that's our answer. Okay, so I'm going to do that again, but I'm going to use the function notation. So I'm going to use a red pen. I got a new red pen, so we'll try with this. So first of all, I'm going to write f of x is equal to 2x minus 3. Whoops, hang on there. F of x is equal to 2x minus 3 divided by x squared minus 4. So u of x is the top part and v of x is the bottom part. So let's write that down. So we have u of x is equal to 2x minus 3 and v of x is equal to x squared minus 4. So it's almost exactly the same as over here, except over here I've got u is equal to and v is equal to. Here I've got u of x equals and v of x equals. So if I have u of x is equal to that, I can differentiate and I get u dash x. So u dash x is equal to, we'll differentiate 2x minus 3 and I just get 2, the same as over here. Here I get v dash x, differentiate x squared minus 4 and I get 2x, the same as over here. And then the quotient rule says that if f of x is equal to u of x over v of x, then f dash of x, which is what we're looking for, is, and it would be v of x times u dash x minus u of x times v dash x all over v of x all to be squared. Okay, so let's just fill into that. So we've got f dash of x is equal to v of x, so x squared minus 4, so x squared minus 4 times u dash x, so times 2 minus u of x, 2x minus 3, times v dash x, so times 2x all over v of x squared, so v of x is this, so x squared minus 4 all to be squared. And this line here is exactly the same as this line over here. So that means when I simplify all of this, I get the same thing as I have down here. I'll get this. So I'll end up with minus 2x squared, as long as I've done it properly, multiplied it out properly. I'm sure I have. Minus 8 plus 6x all over. And again, don't worry about squaring out the bottom. Just leave it as x squared minus 4 all to be squared. Okay, let's try one more example where we have to differentiate this time. We're going to differentiate 1 all over x plus 1. So I'm just going to do this very quickly. I'm going to use the, say, function notation. So f of x, we have to differentiate that. Let's say f of x is equal to that, so equal to 1 over x plus 1. U is the top part, v is the bottom part. So I have u of x is equal to 1. v of x is equal to x plus 1. So now I'm going to differentiate these two things. So I have u dash x is equal to, we'll differentiate 1 and I actually get 0. It's a constant, so when I differentiate it I get 0. V dash x is equal to, differentiate x, I get 1, differentiate a constant, I get 0. So differentiate this whole thing and I get 1. So then by the function, or the quotient rule, this rule here, we're going to get f dash of x, so f dash x, which is what we're looking for, this function differentiated, is v of x, so x plus 1 times u dash x, so times 0, so that's going to give us 0 when we multiply it, minus u of x, so times 1, or 1 times v dash x, so times 1, all over v of x, x plus 1, all to be squared. So when I tidy all that up, I get, well, all of this times 0 just gives us 0. So I'm left with 0 minus 1 by 1, so I'm left with minus 1 all over x plus 1 squared. So if you remember what that means, actually, just while we're at it, we're asked to differentiate this. This is a function, and when we find f dash of x, we're finding the slope of a curve. So the slope of this curve is minus 1 all over x plus 1 squared.